Now the next topic of discussion is boundary conditions. Conditions in case of electric field when it is changing from one medium to another medium, and the medium may be conductor or dielectric. So if the electric field is changing from from one dielectric medium to another dielectric medium, or from conductor to dielectric medium, or from conductor to conductor, in all the cases what characteristics it will follow, what component of this will change. So we will try to discuss that thing today. Okay, so first case we will consider the dielectric interface. It means the field is the boundary at which the field is crossing is the dielectric material. Both of them are dielectric material. So the first one, dielectric interface. This is very simple topic and very important also. So if you will concentrate, then it is just process and a sequential procedure. You can understand everything very easily. So just try to concentrate. Let us start having two dielectric material, the material 1, material 2. Okay, and every material is defined with the help of its permittivity. So its permittivity can be epsilon 2, its permittivity can be epsilon 1. Okay, so electric field is moving in this medium, that is E2, and when it enters from here, then in this region the electric field will be E1. Just we want to know what changes are occurring in this when it enters in the another medium. Okay, and this is E2, this is E1. There will be two components. One component will be the parallel to the boundary, or we can say tangential to the boundary. Any circle is there, the plane or the line, the surface that is normal from the tangent to the surface is known as tangential. So if we will try to match, then we find this is similar to that. So this component is known as tangential component. So we can say ET2, and here it will be ET1. And this component is called normal component. This is the tangential, this is the normal, EN2. Okay, so E2 can be written as E tangential plus E normal. Okay, similarly E1 can be written as E1 tangential, that is tangential to the surface of interface, and E1 normal. Similar to E2, E1 can be written as E1 tangential plus E1 normal. Okay, so this is similarly, if E1 is there, then if we multiply the permittivity of the medium, then E1 E1 E1T plus E1 N. We can write, just we are multiplying with the permittivity of the medium. So we just can multiply to all the terms. It will not affect the equity, the rule of the equal sign. So in that case, what we can say, this is D1. Okay, what is this? The flux density. D1 can be written as D1T plus D1N, because we have studied that D can be written as epsilon E. Already we have discussed this. Similarly, D2 can be written as flux density in this field, in this medium, can be written as D2T plus D2N. Okay, so in this way, the electric field and electric flux density we have written like that. Okay, and if at the boundary we consider a closed surface, at the boundary, if we consider this surface, okay, then it is the width of the considered part and this is height of the considered part, the closed surface. Name it A, B, C, D. Okay, according to the discussion, we know that in any closed surface E dot dl is equal to 0. Okay, it means just follow it and you can write for all these surfaces, you can write it. So E dot dl when you are moving from A to B, when you are moving from B to C, E dot dl, when you are moving from C to D, E dot dl, and when you are moving from D to A, E dot dl, you can write, and it must be equal to the 0 because it is a closed loop, and we know that in a closed loop E dot dl is equal to, already we have discussed and in detail. Okay, now for component AB, when you are moving from here to here, in that case you have ET1 component only, E1N component is absent when you are moving from here to here. Okay, so in that case you can write ET1 and if you will integrate this dl, then that will be full length from here to here. That is how much? That is del W. Okay, now next is the direction of EE. The direction of E is upward here, E is upward here. Okay, and now the according to your closed path, the direction of movement is in opposite direction. So the dl is in opposite direction, however E is in, E means either E1n or E2n is in the up direction. So for that part, if it is considered as dl, it is considered as E. Both are in opposite direction. So the angle between these two will be 180 degree and dot product of these two will give you -1. Okay. So you can say E1n, okay, this is E1n times how much? Half of the, consider this is half part, half of the height, full height. This height will be this height divided by 2. So you can write like that. However, the dot product will give you minus sign. Okay, hopefully it is clear. Now proceed in this direction as well. Same will be followed. However, at the place of E1n, you are taking E2n now, because you are in second medium now. Then you will write E2n delta H by 2. Okay. Now you are at this point, you have to move in this direction. So in this direction, the del L will be in this direction, positive will be in this direction, and E will be in this direction from here. See, ET2 in this direction. The angle between this E and L will be 180 degree, and again it will follow the negative sign. So after that you can write E, this is T2 del W. Hope it is meaningful to all of you. Okay, now you are here, you have to move in this direction. In that case, you can write E into del H by 2. See, now you are moving here. This is E into direction, and this is del DL direction. So both are in the same direction. The angle between these two will be 0, and the dot product will give you 1. Here it is just opposite. One is in this direction, E is in this direction, 180 degree. Here 0 degree. So you can say E into del H by 2. Same way here as well, plus E in 1 del H by 2. There should not be any confusion up to this point, and it must be equal to the 0 according to the, for any closed loop E dot dl will give you 0. Now simplify this. This term and this term, this and this will be cancelled out. The remaining quantity is ET1 and minus ET2 will be equal to the 0. So after that, what you can say, ET1 is equal to ET2. What you can conclude from here? You can say from here that if your electric field changes the medium, then its tangential component remains same. Okay, so it is continuous if it changes the medium. So you can write one sentence: tangential component of E is continuous in case of changing the medium. Okay, you can write dt1 by epsilon 1 is equal to dt2 by epsilon 2. From here what you can say, dt1 and dt2 is not equal. It means the flux density is discontinuous at the boundary. In this way, we came to know that tangential component of electric field is continuous. However, the electric flux density is discontinuous at the boundary. Okay. Now, let us try to find the another component of the electric field or electric flux density. So that is, consider the same, and now consider a surface at the boundary like this, and same component, the electric flux medium 1, medium 2, permittivity 1, permittivity 2, the D1 electric flux density D1, flux density D2. Okay. Now D T2, D2N, DT1, DN1. If we have this configuration, then according to the Gauss law, D dot ds will be equal to the flux enclosed. Okay, we have studied this already. Now, according to the Gauss law, D dot ds will be charge enclosed for full closed surface, and from here we find this is one surface, this is another surface, and the curved surface is the third surface. And if the thickness of the boundary tends to 0, as it is, if it is 0, then we can assume that no flux is passing from there. Okay, so if there is no flux that is passing from the curved surface, then the total flux will pass from the normal surfaces. According to that, we can say dn1 dot ds. See here, the ds area vector, field vector, both are in the same direction. Area vector, field vector, both are in the opposite direction. So this will be positive and this will be negative. So dn1 del s plus minus dn2 area vector times will give you the charge enclosed, as there are no another surface, because we have assumed that del H is, there is no flux from the third surface. Now dn1 del s minus dn2 del s q enclosed, we can write like this. Okay, and what is q, by the way? Surface charge density into the area vector, total surface area. So from here we can say this can be cancelled out, and dn1 minus dn2 will be equal to the charge surface charge density rho s. If there is no free charge at the surface, it means rho s is considered as 0. In that case, flux density dn1 will be equal to the dn2. Okay, so from here we can give an statement that if there is no free charge at the surface, in that case the flux density is continuous at the boundary. Normal component of the flux density is continuous at the boundary. So what we can say, the electric flux density normal component is continuous at the boundary. Okay, and from here what we can write, epsilon 1 E1 minus epsilon 2 E2 is equal to rho s. Okay, so from here we can say electric field is normal component of electric field is discontinuous. So we can say En1 is discontinuous at the boundary. Okay. Now this is the first case when we consider dielectric and dielectric interface. Now consider dielectric and conductor interfacing. So in that case, if we consider dielectric and conductor interface, then and conductor interface. In that case, for example, this is the boundary and this is our medium 1, epsilon 1, E1. Here in conductor we know E will be equal to the 0. Okay, in conductor. So from here, as we came to know that tangential component of electric field is continuous at the boundary, and as E is 0, so what we can say, Et1 will be equal to the Et2 will be 0 at the boundary, as E is 0. And from here what we can write, dt1 by epsilon 1 will be equal to 0. What we can say, dt1 equal to 0. Okay, and in case of Gauss law, we can say d dot ds will be equal to the charge enclosed. Okay, and from here we can write dn1 is equal to rho s, as n2 is, there is no flux density in n2. In that case, this is 2, this is 1. Now we can write dn1 is equal to rho s in case of conductor, if the field is the interfacing is dielectric and conductor.